Hey everybody, welcome back to Math 30-2. We are on lesson 2 of the probability unit and we are going to be looking at odds for and against. Make sure you have your calculator out, grab some paper and something to take notes with, and let's get started. So another way to describe the chance of an event occurring is called odds, and that might seem odd. And you might heard it before when we talk, for instance, of the odds in favor of an event occurring is simply the ratio that compares the number of ways the event can occur to the number of ways that the event cannot occur. And we determine odds using the following ratios. So first of all, odds in favor. So odds in favor, the ratio is expressed as, first of all, the successes of an event occurring, followed by the failure of an event occurring. The opposite of that is the odds against, and that equals the number of failures of an event occurring to the number of successes of an event occurring. And these two numbers must equal the total number of events. Now, the way I like to say that is that the number of the total must equal the number of the success of the event occurring, so the number of the event, plus the number of not the event, or the failure of those occurring. So let's look at a couple of examples to kind of bring this point home. So out of 25 people, 10 are teenagers. So what are the odds that the person chosen is a teenager? Well, the number of teenagers, or the number of successes in this case, would be the number of teenagers, which is 10. Now, because there are 25 people, the number of not teenagers equals the number of the total minus the number of teenagers, which in this case is 25 minus 10, which is 15. So if we were to say, what are the odds that that person chosen is a teenager, we would say that it is 10 to 15. Now, this is not in simplest form. We want to make sure our ratios are simplified, and it's the same kind of idea as simplifying fractions. We're going to divide both sides by the common factor of 2 in this case. So we're going to say, 5, and we're going to say 2 to 3. So for every 2 people in a group that are teenagers, there are 3 people in the group that are not teenagers. Well, let's look at example 2. A bag contains 5 yellow marbles, 3 white marbles, and 1 black marble. What are the odds against drawing a white marble from the bag? Well, to figure out the odds against, we need to know the number of ways there can be a white marble and the number of ways where there can't be a white marble. So we're going to say the number of ways for the white marble is 3, and the number of ways for not a white marble, we can say E bar, is going to be 5 plus 1, which is 6. Now, because this is the odd against, we have to have the odds starting with not a white marble first. So that's going to be 6 to 3. Now, both of these numbers are divisible by 3, so the odds then are going to be 2 to 1, which means for every 2 marbles that are not white, there's going to be 1 marble that is white. Let's look at number 3. What are the odds of randomly selecting a dime from a dish that contain 11 pennies, 6 nickels, 5 dimes, and 3 quarters? Well, the number of ways there are dimes, we can change that up. We can call it D instead. That equals 5. And then the number of ways that it is not a dime is just the pennies plus the nickels plus the quarters all added together. Well, that equals 20. Now this says the odds of randomly selecting a dime. So that's the odds for a dime. So we're going to say 5 to 20. In this case, we can divide both by 5. So the odds are 1 to 4. So for every 1 dime, there are 4 coins that are not dimes. Keep going. So for number 4, 11 poker chips are numbered consecutively 1 through 10 with an extra 6 and placed in a jar. A chip is drawn at random. Find the probability of drawing a 6. Okay, so first of all, there are 11 chips, 1 through 10, with an extra 6. And we know in this jar there are 2 6s out of the 11 chips in total. So we want to find what is the probability of drawing a 6. So the probability of 6 would equal the number of 6s divided by the total number of chips. So the number of 6s is 2, the number of chips is 11, and we can't reduce this further because we have the 2 on the top, and 11 is odd. So the next question is, what are the odds of drawing a 6? Well, the odds of drawing a 6 is how many 6s are there? Well, there's 2. And how many non-6s are there? Well, that's going to be 11 minus 2, which in this case is 9. So the odds is 2 to 9. For C, what are the odds of not drawing a 6? Well, when we already know the odds of drawing a 6, to find the odds against or of not drawing a 6, we're just going to flip the odd statement around. We're going to say 9 to 2. So for every 9 numbers that are not 6, there are 2 numbers that are 6. So let's look at number 5. The odds against Nico randomly selecting a country song from a playlist are 345 to 105. So that means there are 345 country songs and 105 non-country songs, and they don't specify the genre. So here it's asking now is to state the probability of Nico not selecting a country song. Well, first of all, we need to know the probability of, let's say, not country equals the number of not countries. Let's get rid of that little thing right there. So the number of not country over the total number of songs. Well, the number of not country, that equals 105. And the total number of songs, well, that equals the total of country songs plus the total of not country songs. Now, those together, those there add up to 450. Make sure you take your calculator out and check my work. So now that we have these two numbers, we can find the probability of not a country song. So that's going to equal 105 over 450. Now we're going to want to reduce that down. If we divide top and bottom by 5, that's going to get us 21 over 90. And then we can do actually another one reduce. We can divide top and bottom by 3. And that's going to give us 7 over 30. And now it can't be reduced down any further. So the probability of not a country song is 7 over 30. Now let's look at the next one. It says the odds in favor of an event happening are given below. Determine the probability that each event will happen. So we know that the probability of an event happening equals the number of the event plus the number total. But now remember that the number total, I'll just write this over here, equals the number of the event plus the number of not the event. So in this case, the number of the event is 3, and the number of not the event is 5. So we're going to say 3 plus 5 on the bottom, or 3 over 8, or 3/8. Here we'll look in 3. Let's look at the next one. We want to find the probability of the event for B happening. Well, we need to know what is the number of the event occurring. And we're just going to go right ahead and say this right here. The number of the event divided by the total number, which is just the number of the event plus the number of the not event. So that's going to give us 4 over 4 plus 1, which is going to be 4/5. Now this one is actually one that makes a nice decimal. Let's put it in there just so you know that we still can be using decimals. To one decimal place, it rounds nicely to 0.8 because it continues on like 0 like that. We can get rid of those. So the number, or the probability of the event happening when the odds are 4-1 is 0.8. So let's keep going. Now Sintra scores a goal 11% of the shots she takes. Now remember, for probability, even though she has 11% chance, that probability can be written as a fraction. So the probability of a goal equals 11 over 100. So for every 100 shots, she scores 11 times. Identify the odds against her scoring the goal. Well, if we know that the number of goals out of 100 is 11, that means the number of not goals or not scoring is going to be 100 minus 11, which is going to equal 89. So what are the odds against her scoring? Well, the odds against her scoring are the number of not getting a goal to the ratio there of getting a goal. So that's going to mean we have 89 to 11. So the next one. What is the probability that an event will happen? The probability that an event will happen is given below. Determine the odds against that event happening. So in order to figure out the odds against, we need to figure out the number of ways it cannot be the event, and that's going to be to the number of ways of the event. Now we're given the probability. We're going to start by rewriting these probabilities as a fraction. Now remember, to make something into a fraction, we move the decimal 2 places to the right to give us 35, and we put that over 100. So that means that in this case, we have out of 100, the number of the event happening is 35, which means that the number not happening is 100 minus 35, which is 65. This means the odds against are going to be 65 to 35. Now dividing both sides by 5, that's going to give us 13 to 7. Let's do it again for when the probability of A occurring is 0.1. Well, this one here, we can say, just to keep it the same, it's going to be 10 over 100, but that reduces down to 1 over 10. So the odds, or the number of ways we can have A occur, is going to be 1. where the number of ways A doesn't occur is going to be 10 minus 1 or 9. So the odds against A happening is going to be 9 to 1. Let's look at number 9. The probability that Jason will receive a text message during math class is 2/3. What are the odds against him receiving a text message? So we want to figure out what is the number of ways of getting the text message. Sorry, not getting the text message because it's against that, to the number of ways of getting the message. Well, we know that the number of ways of receiving a message is 2. That's that 2 in the top there. So we're going to say the number of M's is 2. But the number of M's like that, remember, we can just take the total, the number in the total, and subtract the number of M's, which is going to give us 3 minus 2, which is going to equal 1. So the odds against him receiving a text is 2 to 1. So for every 2 messages that he does not receive in class, he receives 1 during the math class. Let's look at number 10. The odds in favor of Patricia passing her driver's test is 4 to 3. It's asking us to determine the odds against Patricia passing her driver's test. Now remember, when we want to go from odds in favor to odds against, we simply just have to flip this around, because now we have the failure to the success. So that's failing and that's succeeding. So now we're going to figure out what is the probability that she will pass her driver's test. Well, the probability of a pass would equal the number of ways she passes over the number of the total. Well, the number of ways she passes is the first part in the odds in favor, or the second part in the odds against, and we have 4. Well, the total is just the sum of the 4's and the against, which is 4 plus 3, which is 4 over 7. So the odds she will pass, or the probability, she will pass, is 4 to 7. Well, let's look at the number 11 here. The door prize at a party with 25 people is given by writing numbers 1 through 10 in the bottom of the paper plates used. Okay, so what is going on here? You go to a party, they have paper plates, everybody gets one, and on the bottom, they put a number 1 through 25. So everybody has a different number. It says, what is the probability that an individual has a winning plate? So somebody draws one number out of 25. Therefore, the probability of winning, which equals the number of ways you can win over the total number of outcomes, is going to be one way to win, because they're only picking one number, over the total number of numbers to choose from, which is 25. But now it's asking, what are the odds of winning the door prize above, and what are the odds of not winning? So what are the odds for a win, and what are the odds against a win? Well, the first one, we want to say the odds of winning is the number of wins to the number of not winning, which means, well, how many ways can we win? There's only one way. But the not winning, you have to think of the total number minus the win. So the odds of winning are 1 to 24. But the odds of not winning, let's be here. So this is odds 4. So that means the odds against are just going to be flipping that thing around, so that not winning comes first, followed by the win. Number 12. If the odds in favor of an event occurring are 7 to 5, what is the probability of the event occurring? So let's look at this. This is odds in favor. So that is the n of the event occurring is 7. The n of not the event, or the number of not the event, is 5. So the total number is just those two added together, which is 7 plus 5, which is 12. So we're asking what is the probability of the event occurring? So that is going to be the number of the event over the number of the total, which is going to be 7 over 12. Number 13. If the odds against an event occurring are 9 to 14, so this is the odds against an event occurring. So this is how many ways it doesn't occur, not, and this is the way it does occur. The question is asking, what is the probability of the event not occurring? So we want to find the probability of this. So we need to know the number when it's not that divided by the total number. Well, the number that it's not is the 9, and the total number is going to be the 9 plus the 14. So that's going to give us 9 over 23. Now, we can't reduce this any further, so our final answer is 9 over 23. Let's look at 14. This time, I'm going to read it out, and I want you to pause the video, see if you can figure out the answer, and then come back and see how you did. In Canada, a statistical study shows that 10% of people aged 70 or over will suffer a stroke within 5 years. What are the odds against a person aged 70 or older suffering a stroke within 5 years? Like I said, take a moment, pause the video, come back and see how you did. Now this one has a lot of numbers that actually don't have to do with any of the kind of calculations for the odds for or against. We know that 10%, we often have used that. So that means 10 out of 100 people age 70 or older. So that 70 actually doesn't get calculated into anything here. It's just letting us know that that's the age of the people. And same with the 5 here. This is just telling us how long a person 70 or over will suffer during that time period, will suffer a stroke within a time period. So sometimes questions have numbers that have nothing to do with the actual calculation. So just be aware of that. So if 10% of people age 70 and over will suffer a stroke, that means out of 100 people, the number of people that will suffer a stroke equals 10, which means the number of people that do not suffer a stroke is going to be 90. So the question is, what are the odds against? Well, that would be 90 is our odds, or our number against. For our numbers, for our 10, now we're going to reduce this down 9 to 1. So if you said A, you're right. Let's do that again. Harvinder is considering a medical procedure where the risk of a complication is 80%. How would the odds for a complication be expressed? Again, pause the video, give this a try, and then come back and see how you did. So let's look at that one. So Harvinder has an 80% chance of risking a complication. So in other words, out of 100 times, the number of times you will be risking something is going to be 80, whereas the number of times you won't be risking anything is going to be 20. Now this question is, how would the odds for a complication? Well, in that case, complication is the risk of complication. So we're going to say it's 80 to 20. Now both of these are divisible by 20, so the odds is 4 to 1. Another A. Let's try the next one. The odds against correctly guessing an answer to a multiple choice question with 5 possible answers is, we'll define the odds for correctly guessing. So what are the number of ways we're going to guess correctly? Well, in a multiple choice test, there's only one correct answer out of all the possible answers. That means the total of answers that are not right or are 5 minus 1, which is 4. So the odds against guessing correctly would be 4 to 1, which would be A. Let's look at 17. The odds in favor of a horse winning a race are posted at 6 to 5. So that's the odds in favor. So this is win. This is not win or lose. What is the probability that the horse will win the race? So the probability of a win would be the number of wins over the total number. And we remember from before that the total number is going to be the sum of the wins and the losses, which is 6 plus 5, which is 6 over 11, and we can't reduce that down any further. So our answer in this case is B. Finally, a B, not an A. Just a couple more to go. A survey of Alberta students was used to estimate the percentage of students who participated in school and non-school athletics, as well as the percentage who do not participate in any athletics. The result of the survey are shown in the Venn diagram below. So remember the intersection here. This means that 38% take both school and non-school activities. This means that 15% take only school activities. And this means that 26% take only non-school activities, which means the last number here is that 20% or 21%, take neither. So the question is, what the odds in favor of randomly selecting an Alberta student who participates in school athletics are what? Well, if they're participating in school, the number who participate in school equals, out of 100, say, because we have been given percent, so we're going to say 100. So it's 15 plus 38, because we have to consider, even though these guys in this region take both, that means that 38% still take school that have not been included by this 15. So we have to add these both together. So when we do that, we get 53 people, or 53 out of 100 people take school-based activities. Now, what are the total? Well, the total again here is 100. So we can do it two ways. We can say the N of not taking either of these athletic pursuits, school or non-school. We could say it's 100 minus 53, or we can say it's 26 plus 21, and that's going to give us 47. So what is the odds in favor? The odds in favor would be 53 to 47, and would be D. All right, let's look at number 19, so close to the end. What are the odds against randomly selecting an Alberta student who does not participate in any sports? So they're not participating in any sports. And that's the odds against them. Okay, well, first of all, the number of ways they're going to not participate. What are we going to, let's call that neither, N for neither. Neither sport. Well, we know out of 100, that's going to be 21. So that means the total that are not taking neither, in other words, they're taking one or the other or both, that's going to be 79. So in total, it says, what are the odds against? Well, that would be 79 to 21. And the last one, thanks for holding in to the bitter end. A newspaper article claimed that a new medication doubled the probability of successful treatment compared to an older medication. The odds of the older medication being successful in the treatment were 3 to 7. Okay, so in other words, for the old medication, the number of successful treatments was 3 to the number of unsuccessful treatments, which was 7, which means the probability of success is going to be the number of successful over the total number, which is NS plus NS bar, which equals 3 over 3 plus 7, which is 10. And that actually makes a nice little decimal. We can put it as 0.3 if we wish. And they tell us, though, that the new probability, let's call this probability 2, for success has to be double or 2 times the probability of that. Now we can write it as a decimal to get 0.6 and then convert that to the fraction, and we're just going to get 6 over 10. So that's our new probability. Now the question is saying, what is the odds in favor of the new medication being successful? So based on our probability, the N of success equals 6, where the N of not successful is going to be the total minus the N of success. In other words, I know this is the fancy math way, but we're going to say 10, that's the total, minus 6, which is 4. So the odds in favor is going to be 6 to 4, but we want to make that into a reduced odds statement and say dividing each side by 2, we get 3 to 2. And we're done. Well, that's the end of this lesson. If you have any questions, make sure you let me know. Otherwise, I hope you have a great rest of your day. Take care.